The scientific reason why baby animals grieve just like humans lies in the deep evolutionary importance of social bonds for survival. Across species, babies are born dependent on parents not only for food but also for protection, learning, and emotional comfort. This dependency drives the development of strong attachment systems that bond infants to mothers or caregivers from birth. Neuroscientists studying attachment across mammals have discovered that the brain mechanisms governing these bonds are surprisingly universal. In both human infants and baby animals, the release of oxytocin strengthens attachment and creates feelings of safety and comfort. Oxytocin, often called the love hormone, triggers positive feelings during physical touch, nursing, grooming, or close contact. When the caregiver disappears, baby animals experience a sharp drop in oxytocin paired with a spike in cortisol. Cortisol is the body's primary stress hormone, released when an infant feels unsafe, abandoned, or vulnerable to predators. This stress response, seen in both humans and animals, triggers vocal distress calls meant to summon the missing caregiver. In baby animals like primates, elephants, and even rodents, separation from their mother activates these same stress circuits. The longer the separation lasts, the more prolonged and damaging the cortisol surge becomes for the baby's developing brain. Studies show that infant animals deprived of maternal care develop long-term behavioral and cognitive deficits, similar to human trauma. This overlap in brain chemistry and stress response helps explain why baby animals show such profound grief after maternal loss. In elephants, orphaned calves often linger near their mother's body, emitting high-pitched distress calls for days. Even when the herd moves on, these orphans display withdrawal, reduced feeding, and signs of depression-like behavior. These responses mirror human children's grief behaviors, including loss of appetite, disrupted sleep, and social withdrawal. Orphaned primates show similar patterns, clinging to surrogate objects, self-soothing, and showing heightened anxiety in unfamiliar situations. This attachment grief cycle is not learned, it's hardwired into the infant brain for species where social bonds equal survival. Human children who lose parents often show nearly identical stress responses, revealing the evolutionary origins of grief itself. The brain regions regulating attachment, separation distress, and grief evolved long before modern human culture appeared. In fact, researchers using brain imaging have found strikingly similar activity in grieving humans and grieving animals. The anterior cingulate cortex, a brain region involved in processing social pain, activates in both species during loss. This social pain circuitry evolved to make separation emotionally intolerable, ensuring infants stay close to protective caregivers. In mammals, prolonged separation often led to death, making the evolution of separation distress essential for survival. Baby animals' grief isn't just sadness, it's a powerful survival mechanism designed to restore lost contact with caregivers. When reunion is impossible, the emotional and physiological damage caused by extended grief can alter the developing brain. Studies in orphaned monkeys show permanently elevated cortisol levels, increased fear responses, and impaired social bonding later in life. These long-term impacts resemble human childhood trauma, which increases lifelong risk of anxiety, depression, and attachment disorders. This shared biology is why scientists now recognize that grief in baby animals isn't just anthropomorphism, it's biological fact. Elephants, dolphins, and primates show the most complex mourning behaviors, but even rodents display measurable grief responses. Orphaned baby rats vocalize distress at higher rates, show reduced exploratory behavior, and exhibit stunted weight gain. Scientists studying these patterns see clear parallels between infant animal grief and the attachment theory developed in human psychology. Attachment theory describes how infants form emotional bonds to caregivers, using them as a secure base for exploration. When that base disappears, infants experience fear, distress, and withdrawal, reactions equally present in both species. Attachment and grief are two sides of the same biological coin, with loss triggering the same circuits that form the bond. In species with long parental care periods, the loss of a caregiver can permanently reshape the infant's stress response system. This early trauma leaves baby animals hypersensitive to future stress, reducing resilience and social competence as adults. In primates, this disrupted attachment can lead to social avoidance, impaired mating behavior, and difficulty forming stable relationships. Baby elephants orphaned by poaching often grow into socially unstable adults, struggling to integrate into wild herds. The link between early loss and lifelong challenges highlights how grief functions as both an emotional and biological process. Scientists now believe the capacity for grief evolved precisely because social species rely so heavily on lasting family bonds. These bonds, essential for survival in complex environments, ensure infants learn essential skills through close parental guidance. Losing that guidance disrupts not just emotional security but also learning pathways essential for survival in adulthood. Grief in baby animals isn't just emotional pain, it's the brain's way of signaling a catastrophic disruption to development. This overlap between human and animal grief reflects deep evolutionary roots shared by all species with prolonged parental care. Even birds with strong parent-offspring bonds, like crows and albatrosses, show distress behaviors after losing a parent. In some species, grief behaviors include reduced feeding, aimless wandering, and attempts to follow the lost parent's scent trail. These cross-species patterns further confirm that grief isn't a human invention, it's a shared legacy of social evolution. The stronger the parent-offspring bond in a species, the more intense and prolonged the grief response after loss. This explains why highly intelligent and social species like elephants and dolphins display some of the most elaborate mourning. Dolphin calves separated from mothers often refuse food, vocalize continuously, and shadow boats or other dolphins for comfort. These behaviors parallel human children's desperate attempts to reconnect with lost parents after sudden trauma. Even though the language of grief varies across species, the underlying biological mechanisms are remarkably similar. This growing body of research forces scientists to rethink assumptions about animal emotions and the depth of their social bonds. Rather than viewing animal grief as a rare quirk, scientists now see it as an adaptive response embedded in social species. Grieving baby animals don't just miss their parents, they experience a biological crisis triggered by broken attachment bonds. This biological grief serves as both a cry for help and a powerful signal to nearby social group members. In species like elephants and dolphins, social groups often respond to orphan distress with comfort, grooming, or alloparental care. These social support behaviors, also present in human families, help buffer the damaging effects of early loss on young brains. The ability to grieve may have evolved alongside the capacity for complex social cooperation and interdependence. For baby animals, grief is both a distress signal and an adaptive mechanism ensuring survival in cooperative species. Understanding the science behind animal grief deepens our appreciation for the emotional lives of non-human species. It also challenges outdated ideas that grief and attachment are uniquely human experiences rather than evolutionary necessities. Ultimately, the scientific reason baby animals grieve like humans is simple: because survival depends on love and loss.